Hello guys, this is Rishabh Mehan and I'm on my major project developing video quality metrics based on the optical flow in a motion media. This project is supervised by Dr. Vikas Saxena. So, coming on to this project, we have created this project on Visual C++ 2008 with the use of the OpenCV library. OpenCV library is a computer vision library by Intel which enables us to do the image processing that we need. In this project, what we are doing is taking a video input and outputting the quality metrics of that video according to what user perceives it. The most of the quality metrics is available like PSNR, MSQ, mean square errors. That is totally based on the objective analysis of the video, but here we are trying to do the subjective analysis. Subjective analysis is what user sees it and tells us how he is perceiving the video. So let's start out with this video. It's a normal video and this is how we are doing it. First let's see how the code runs. Over here we have got the frames. Total number of frames available is 304. So this is the projection. Here we have the purple arrows and the green arrows in this screen. The purple arrows are showing the motion of the video, of the complete video. The motion is the left directed motions and the green arrow are showing the right directed motions. We are calculating the motion obstruction flow in this video, and which is being shown on this screen over here. As you can see, there are values being calculated over here. We have a frame number, we have got the left arrows, the right motion, the total found of the number of features. We have then calculated the Now we are here calculating the motion obstruction flow ratio. The motion obstruction flow ratio is being calculated by the use of the total number of the motion which is causing the left sided motion in this video and the right sided motion. That means the purple arrows versus the green arrows. And also to keep that image, actually it's all the frames and each frame is having one image. So each frame is having a specific dimensions, like this frame is having 640 by 480 dimension, and maybe some video may have 320 by 240 pixels. So in that case we are also using the aspect ratio of that video. If we show you in the code, we can show you perfectly what we have done. We have found the total number of features minus the negative of the maximum features divided by the total number of maximum features of that video. So if I'm clear enough, I can show you that motion obstruction is caused by the green arrows, the opposite direction of the complete video. After calculating the motion obstruction flow ratio, we calculate an optical flow based on this motion obstruction flow. It is the estimated optical flow that we are calculating over here, which requires us to divide the ratio of the maximum motion with the motion obstruction flow ratio. By getting the difference of the motion obstruction flow with the maximum ratio of the video, we get estimated optical flow over here. After running a video again and again for like till its frames exhaust, we get a value of optical flow, and after we have got all the frames optical flow, we actually sum them up, we take them together, and we actually take a ratio of the total number of pixels in that video, and we take a ratio of that optical flow, of that sum of the optical flow with that pixels, with those pixels. With that we get a video quality matrix which is shown over here. As you can see, the end result is we calculated a video quality matrix of 0.217. Well, we have different values also in the output, like the left motion, the right motion, total found motion, total features that are being tracked. So we can see there is a difference, 6917 and 6853. We have total features 6917, but we are getting 6853 features which are being found. So we have taken in count of that frame drops, that those motions which are not being recognized, those features which has not been accounted, that are being taken in consideration. So when we get the final value, we have it. In this project we have 0.1 as the threshold value for the good and the bad videos. Below the threshold value, the videos will have a poor quality. We'll show you with the next video. We come up with the next video now, and as you can see, the video which we used right now was this video, and it is quite clear. This one's quite clear. Now we have edited this video and made it up to something different, and now we have edited that video to make it look worse than worse. So this is that video which we have edited, and so it's like, for a user it has a very bad quality. It has been changed, it has been like ruined totally. So now we're gonna run our code on this. Okay, here's the debugging that has been going on. Similarly, we have got the number of frames 304, exactly same as the previous video. Now we are calculating the motion. As you can see that the left motion is still there, but with a lot of green motion in many other directions. So this is because of the video processing that we have done earlier on this video, that the quality hindrance has been there. And we can see the motion is being still calculated over here. The motion obstruction flow ratio is shown. The ratio of the maximum motion is also there, and the optical flow is also being calculated for each frame, and all these frames are getting summed up in a variable over here, sum. Now when it has stopped processing the video, we get a video quality, and over here it is showing 0.07. And that's how we can show that our video quality has decreased. Earlier the video quality was 0.217, and now we are getting only 0.07. So our video quality metric software is working perfectly fine on our videos, or to judge the video whether a user can perceive it correctly or not. We have over here many other videos also that we have tried. We can show you another video which has been augmented, which has been transformed. The another video is over here. We'll just change a bit of code, and I'll show you the video as well. So here's that video. Very fuzzy, very fuzzy. It's a complete negative effect of that video. Okay, so now we're gonna implement our code on this video. We're gonna debug it. So no errors, and here we are. Same 304 frames over here. You can see it clearly, and now the code runs. So here we are again. It's the same process. Motion obstruction flow ratio is being calculated again and again. Motion obstruction flow ratio is the main element of this project. However, we are using the Lucas-Canade algorithm to find the features to compare the motion of to compare the optical flow. We are calculating it by Lucas-Canade, but to implement the video quality metrics, we have to use the motion obstruction flow in this algorithm. According to me, that in this video what is happening is that there are many like separate motions, but we are actually finding the main cluster of that motion, the opposing motion clusters. We are not looking at for the separate values, separate green arrows. We are finding the main cluster. The center of mass has been found. When we have got the weight, we'll patch that area and we'll call it the obstructing area. And that obstructing area, when compared to the whole image, it will give out the obstruction ratio. After this, now this video has been processed, and here we are with the video quality. As you can see guys, the video quality is still decreasing. The original video has 0.217, and over here we have got 0.017, which has declined in a very drastic manner. Since the video quality is not good, we are showing it is working perfectly. So this was about the videos that we have compared. More for the videos, we have few videos that we have also tried. many videos we call it a good video, which is a cartoon effect, like a 3D model, a 3D video, a cartoon movie. So we have also here a cartoon movie based thing. The frames are over here. I'll first show you the movie because it gets difficult to see the movie when it's in the processing. So here we are with the movie. As you can see, the video quality is not that good. As I'm also seeing it, the video quality is not amazingly good, but yeah, fine, it's good enough. So here we are. So this is the video frames that are being going on. As you can see that this video is comparatively smaller in size, smaller as in the aspect ratio of this is smaller, but we are not looking in for that thing that a video has to be of that particular size or not. It can be of any point, it can be of 100, 100, it can be of anything. If we like, so over here we are calculating the small video. The area of the video doesn't actually matter a lot. We have got here a static background and we have a person standing in between, as shown you in the earlier video. As you can see, the arrows and the pointers are still working perfectly and the values are being calculated over here. As you can see, the motion obstruction flow ratio is constantly being calculated and there are few errors due to the frame drops, due to the uniform motion, which is also being noted down to handle. Okay. So if the size of the video is small, it is not a big problem. In fact, it's not a problem. So now here we have got a value greater than 0.1, which is showing that this video has good quality, but it doesn't have that great quality as the earlier car video that we showed. So it is good. It is fair amount. People can view it easily, and this is my project. Talking about the applications that we can build using this project, if we talk about an application being used at YouTube or any other video internet or video sharing sites, a person can easily upload the video and the server will calculate its video quality matrix based upon what a user can see. So if you can think about that thinking, like what a user can perceive, and that we are also able to tell, the system is about to tell that what our user perceive, it can be a lot of benefit to the company, a lot of benefit to that site, and also users will have a lot of entertainment, a lot of good experience while using that videos. Thank you guys. This was my major project under Dr. Vikas Saxena, and this project has been completed successfully by me. Thank you.